Hello everyone, I'm going to be talking about one of the most important aspects of electrochemistry in Chemistry 12. That's right, today I'm going to be talking about balancing redox reactions. So, there are two different ways that you can go about balancing a redox reaction. You can go with the half reaction method, or you can go with the oxidation number method. So, let's start off with the half reaction method first. So the first step of the half reaction method is to separate your equation into two half reactions. For example, in this equation we have HClO2 plus I turns into Cl2 plus HIO. Notice the Cl on both sides and the I on both sides. Now all you have to do is take the term with Cl's and make them into one half reaction. Like this. HClO2 turns into Cl2. Same thing with the I's now. So you take the I, and then it turns into HIO. So the second step that you do when you're balancing a redox reaction is using major OH. Major OH isn't a COP. Major OH is an acronym we use in Chemistry 12 to remember the steps that we need to take to balance a reaction. Major stands for major atoms. You might wonder what a major atom is. A major atom is any atom that is an O or H. Next up is O. O stands for balancing oxygen. You do this by adding H2O. H stands for balancing the hydrogen. You do this by adding H+. And then the minus stands for balancing electrons. You do this by literally adding electrons. Alright, just in case you guys are confused, we're going to go over a quick example here based off the last example we did. So we have our two half reactions. We have HClO2 turns into Cl2. So when we're doing major OH, we first look for the major atoms. This term, it is Cl. There are two Cl's on this side and only one on this side. So that means we have to put a 2 on the left. Next up is O. Notice that we have 4 O's on the right now. To balance this, we add 4 H2O onto the right side. We're almost there now, but we still have a bit to go. Now we balance H. Notice how there are 8 H's on the right and 2 H's on the left. That means we have to add 6H plus to the left side of the reaction. And now, if you look at the electrons in this reaction, notice that this has a charge of 6 plus over here, while the other side just doesn't have a charge at all. To balance this out, we need to add 6 electrons to give the left side a neutral charge. We're halfway there. Now we only need to balance this half reaction. So we have I turns into HIO. You guys know the drill. Look for the I's, which are the major atoms. Realize they're the same. So we instead go to the next step, which is balancing out the O's by adding H2O. After, we have to balance out the H's. So then we add an H plus to the right. Now we add electrons. Put 2 on the right so that now both sides of the reaction carry a -1 charge. So, now for the third step. For the third step, we must add both of the half reactions together. We do this by multiplying the half reactions to make the electrons on both sides equal. Then, we cancel out like terms, and if you're using basic conditions, you neutralize the H plus by adding OH on both sides of the reaction. Let's take a look at our example. As you can see, there are 2 electrons on the right side, and there are 6 on the left. This is why we multiply the half reaction with the 2 electrons by a coefficient of 3. Now that the electrons are the same on both sides of the equation, we can just cancel them out and move on to our next step. So, as of now, our equation looks like this. 3i minus plus 6h plus 3H2O plus 2HClO2 turns into Cl2 plus 4H2O plus 3HIO plus 3H. So now we just need to get rid of our like terms. Take a look at the H's. Notice that there are 6 H's on the left, 3 H's on the right, so they cancel out, and now there are only 6 H's on the left. Same thing with H2O, 3 H2O's on the left, 4 H2O's on the right, cancel out the H2O's, now there's only 1 H2O left on the right. So we can get rid of that, and our new equation is this 3I plus 3H plus 2HClO2 turns into Cl2 plus H2O plus 3HIO. Now, if this was in an acidic solution, we would be done. However, this is a basic solution, so we must now cancel out the H plus by adding 3OH to the equation, both sides. And that turns our equation into 3I plus 3H2O plus 2HClO2 turns into Cl2 plus H2O plus 3HIO plus 3OH. Now it's time for the second way that we can balance a redox reaction, using the oxidation number method. Now the first step for this method is using, that's right, major OH once again. I trust you guys remember what we did last time, so I'm not going to go over that stuff, but yeah. Now we're going to have a different example. We're going to have TeO3 plus N2O4 turns into Te plus NO3. First, we look at our major atoms. We see the N's, and we realize that we need to add a 2 to the NO3 on the right side. Now we realize that the O, the H, as well as the charges are all the same, so we don't have to do anything else. Now on to our second step, assigning oxidation numbers and determining the change. Back to our example here. We have TeO3 to the 2 plus N2O4 turns into Te plus 2NO3. First, let's calculate the oxidation number for TeO3 right here. So, Te is X. And then we see that O, there are 3 O's. And O always has a charge of -2, and the overall charge of the reaction is 2-. So that's where we get this reaction from. Flip the numbers around, we get X equals 4. Oxidation number is 4. Now, on the opposite side of the reaction, we have Te. As you can see, Te is alone and it doesn't have a charge. That means that its oxidation number is 0. So as it goes from 4 to 0, our oxidation change for Te is 4. But if you want to get technical about it, it is technically -4 as it goes from 4 to 0. Now we go on to N2O4. So as you can see, there are 2 N's in this reaction, so we use 2X as the variable, and then we add 4 O's times its -2 charge equals 0. Do the calculations, we get X equals 4 once again, and the oxidation number is X equals 4. So now we look at its counterpart, 2NO3 minus. So look at 2NO3 minus. There's a coefficient, but we won't worry about that just yet. So we just take the N, use it as X, have the O, since there are 3 O's, 3 to the -2 equals -1, flip everything around, get X equals 5, and our oxidation number is 5. So our oxidation number change is 1. However, we are not done yet for NO2 to NO3 minus because of that exponent right there. You have to multiply your oxidation number by 2 to get the proper oxidation number. Alright, now on to our third step. We balance the change in oxidation numbers. So in this case, 4 on the left, this side is 2. The right side 4. Alright, now that they're both balanced, we can come up with our new equation. However, since we multiplied this side by 2, we must now put 2 onto both of the atoms with N. That leads us to our fourth step, which is balancing the charges of the reaction. If we have an acidic reaction, we use H+, but if we have basic conditions, we use OH-. Then we add H2O to rebalance the reaction, if there are any discrepancies. Alright, now let's look at our example once again. So for acidic conditions, you just add an H+ to the right side, just to balance out the charges, and then you add an H2O on the left to get rid of the extra H's on the right. And for basic conditions, we add 2OH to the left side of the reaction and an H2O onto the right. Alright, that's it for this video, guys. Hope it helped. Bye.